for problem 10. I don't know if you actually need that, but I like to write it up there. But chapter 4, problem 10 does indeed read, a dock worker applies a constant horizontal force of 80 newtons to a block of ice on a smooth horizontal floor with negligible friction. The block starts from rest and moves 11 meters in 5 seconds. So first, find out what is the mass of the block of ice. So, to figure that out, we need to find the block's acceleration, so we can use acceleration and force equals mass times acceleration, because force over acceleration is going to equal rest. So, set up our kinematics. V naught VA dt, or V naught is 0. Final velocity we don't care about right now. Acceleration we're looking for. Distance is 11 meters over the course of 5 seconds, so we can use d equals V naught t plus half at squared. So 11 will equal 1/2 a times 25. So 22 divided by 20, using algebra, 22 over 25 equals a, so our acceleration is 0.88 meters per second. So using previous equation, F over a equals m, our mass is going to be 88 over 0.88, which is 90.9 kilograms. Part B of said problem says, if the worker stops pushing at the end of the 5 seconds, how far does the block move in the next 5 seconds? So to do that, first we need to find our, we'll use our D2 is what we'll call it, and well, this can be T2, but it's going to be equal anyways because they're both 5 seconds. But since after he stops pushing, our acceleration will be 0, which means we'll have a constant velocity, which means we can use d equals vt. We don't know the velocity when he's done accelerating the block, so we solve for it. Using the same numbers here, we can throw our v squared equals v naught squared plus 2ad. So put square root on both sides. Our v naught's going to cancel out because that's 0. So the square root of 2ad is equal to our final velocity. To make things a little easier, we can just multiply that by our time, being 5 seconds, to find our d2, our the distance it moves during the second half. So d2 equals the square root of 2 times 0.88 times 11, all of which multiplied by 5. The 5's outside the square root, everything else is in it. And the block will continue to slide for 22 meters during the next 5 seconds.